one continuous probability distributions. Okay, so look at this. So in one y-axis, we have a probability, and an x-axis is going to be time. The probability distribution here is, you see the maximum point here. It is skewed to the left. It is to the left. That's why we call it, this is a skewed to the right. Because when we talk about the skewed, you have to talk about the narrow end. If the narrow end is on the right, this is the skewed to right. Narrow end, it is skewed to the left, because the narrow end is to the left. Here is the unimodal, because we have one maximum, one mode here. We have one maximum. When we talk about bimodal, is like that. We have two maximum. Here is bimodal. Also, this is symmetric, because the axis of symmetricity can show by a line. So if you just mirror that or with respect to this line, you get the other half. There is no skewness for this shape. It is symmetric, it's unimodal, and there is no skew, it's just in the middle. It's a normal distribution. We'll talk about that later. So let's see if we want to model with the probability density. So the probability density is the probability per unit of the continuous variable. Looking at this question, the driving time between Toronto and North Bay is found to range evenly between 195 to 240 minutes. What's the probability that the drive will take less than 210 minutes? If you draw this, so it's going to be uniform distribution, right? So it means the height is going to stay the same. So the uniform is always the same. So between 195 to 200, 240. This is total distribution that you have. You know the area under that should be 1, right? From 195 to 204. So this area is the probability distribution. This area needs to be 1. The total probability will add to 1. So I can't find this height. I know this length is 240 minus 195, right? But I don't know this height. Let's just put that to be x. This height multiplied by x equals to 1. So it's going to be length multiplied by the height. So x is the height of that is equal to 1 over 240 minus 195. Is equal to 0.022. I know the height is going to be 0.022. And so the probability that drive will take less than 210. 210 is, let's say here, is 210. Less than 210 means you just need to find this area, right? So what is this area? It's just the length multiplied by the width, right? Is 210 minus 190 for this length multiplied by the height we got it from the previous. It's just 0.022. That would be, if you do that, the answer would be 0.33. So we have exponential distribution of y is equal to k e power negative kx, k 1 over mu, and the mu is your waiting time. So for this part, I'm interested that you do question number 1 and question number 2. There's these two questions who paid 419.